Good morning. Today we're looking at section 7.5, integration using computer algebra. So far we've just touched on the surface of integration. As been mentioned, there are a lot of techniques of integration. Since integration really is guess the function that has the given derivative. We have two approaches so far. We started with Riemann sums, which is something for definite integrals. We do this with a spreadsheet, straightforward but tedious. It's really robust, but it only works for definite integrals. In the last several sections, we've been looking at using the fundamental theorem of calculus, and if we have a nice function, we use integration formulas. The problem with that is it only works with really nice functions. So we're going to try one more method. Since everyone has a computer, we're going to look at doing computer algebra. Now, there are four basic kinds of problems we've looked at. We started with definite integrals, the area under a function in a specified region. We looked at indefinite integrals, which is I want a general antiderivative for a given function. It typically has a plus c at the end. We looked at initial value problems where I want a particular antiderivative, and Riemann sums, something we did in Excel, but we always would like to be able to check the work that we do. We're going to look at two systems, Wolfram Alpha and Symbolab. Wolfram Alpha is the more powerful, but the more robust version charges a fee. The free version of Symbolab includes show steps. I think that's always useful because you'll want to be able to use this to check homework and check your drill and make sure you're not making mistakes. So let's start with Wolfram Alpha. I'm going to start with, and you just Google Wolfram Alpha. I'm going to start with a function that we don't know how to take an antiderivative of, the natural logarithm. I simply tell it to integrate the natural logarithm of x. One of the things to note is when it gives its answer, it's going to say log rather than natural log. This is one of the features of Wolfram Alpha. And it gives us an answer of x times log x minus 1. We could take the derivative and see that that's actually an antiderivative of the function, plus an arbitrary constant. I can ask for show steps, but it'll ask me to pay money for that. So this was the indefinite integral. If I ask it to integrate from 1 to 10, it gives me the integral and says I plug those in and it gives me a value. It does along the way show me what the indefinite integral was, so it shows me how to get there, but this is my definite integral. I can do the initial value problem, and I change the syntax a little bit. I'd like to solve for a function whose derivative is the natural log of x and has a specified value at a specified point. It takes the input. It's going to go through and say, I think this is ordinary differential equations, but it gives us the solution and says that c should have been plus 4. So we can do that. The last thing to do is Riemann sums, and you'll find Wolfram Alpha is fairly forgiven when you do syntax. So I just typed in Riemann sum of ln of x from 1 to 10 with 100 subintervals. It will tell me what that is, and it's going to start with the left-hand method. But if I go down a little bit, it says the left-hand method, the right-hand method, the midpoint, and then several methods that we haven't covered in this class. It's worthwhile to know how fast those other methods get towards the answer. So notice that the midpoint rule, as we discussed in class, is much better than the left-hand rule or the right-hand rule. If I wanted to change from 100 to 10,000 points, I can do that without much difficulty. And as we had found in class, if I have more intervals, notice my error is much smaller. So this is Wolfram Alpha, just wolframalpha.com. It's a symbolic method for doing calculus. The other one I wanted to show was Symbolab, and so I asked Symbolab for the antiderivative of ln of x. It tells me the answer The nice feature of Symbolab is it then tells me how it got there. It's using a technique called integration by parts that we don't use, and sets up the integral and gives me the integration for it. If I want a definite integral, I also type in the definite integral. This has a more symbolic palette, so I'm doing the integral using the palette, the integral from 1 to 10. It's going to give the same answer. Again, it shows integration by parts and shows you steps of how to get there. The third one was I wanted to solve, and again, this is a system. I have a derivative of the function is what it is, so I'm looking for the antiderivative and the antiderivative that has a specified value. So in all of these ways, either with Symbolab or Wolfram Alpha, you can check your work that if you're using calculus outside of this class, when your boss says do something and you say, I need to know the integral, saying I don't know how to do it can get you in trouble. Saying I didn't know how to do it, so I looked it up online, that typically is not a bad answer for the boss. That's what we were covering today. Symbolab does not seem to have a Riemann sum function, so we can't use it for that. Thank you.